our polynomial is p of x equals x to the fourth minus 9x cubed plus 9x squared plus 33x plus 14. Our rational candidates are all going to be integer divisors of 14, since the leading coefficient is 1. So plus or minus 1, plus or minus 7, plus or minus 2, plus or minus 7, plus or minus 14. So let's look at the graph that we get, and let's do a window with x min negative 15 and x max positive 15, the largest and smallest possible rational zeros. And now when we graph, it appears as if our zeros are all occurring between about negative 3 and positive 10. So let's bring that in a little bit. So let's go negative 3 for x min and 10 for x max. All right. It does look as if we've got a 0 at 7, I think. 1, 2, 3, 4, 5, 6, 7. So I'm conjecturing that there's a 0 at 7. The others are a little less clear to me. I'm going to come in and make the x max 5. We're going to not be able to see a 7, 0, but we maybe will see the others a little bit better. So 1, 2, 3, 4. Looks like we've got a 0 between 3 and 4. And over on the left side, I think there might be a 0, a rational 0 at negative 1. The other two look as if they are going to be irrational zeros. So let's use synthetic division to see if we're on the right track here. So 7 would be the divisor, 1, negative 9, 9, 33, 14 are the coefficients. 1 will be the leading term in the quotient, times 7 would be 7, add negative 9 would be negative 2. Negative 2 times 7 is negative 14, add 9 is negative 5. Times 7 is negative 35, add 33 is negative 2, times 7 is negative 14, and we do get the remainder is 0. So our actual real zeros do include the number 7. Now let's try the negative 1. One would be the leading coefficient in this quotient, times negative 1 would be negative 1, add negative 2 would be negative 3, times negative 1 would be 3, add negative 5 would be negative 2, times negative 1 would be 2, and the remainder would be 0. So negative 1 is also one of the actual zeros. To find the other two irrational zeros, the quadratic factor that we are left with at this point is x squared minus 3x minus 2. So in the quadratic formula, the a would be 1, the b would be negative 3, and the c would be negative 2. So looking for the zeros of that quadratic function, we'd get the opposite of b, which is 3, plus or minus the square root of b squared, which would be 9, minus 4 times a times c all over 2a, which is 3 plus or minus square root of 9 plus 8 all over 2, which is 3 plus or minus the square root of 17 over 2, and that does not reduce. So our other two real zeros are irrational. They are 3 plus the square root of 17 over 2, and 3 minus the square root of 17 over 2. We have 4 x-intercepts. 2 of them are rational, 2 of them are irrational.